What's up, guys? Welcome to the channel. I'm Aziz here with Primus Learning, and I'm very happy to be pushing out this lecture. And basically, it's a 2 hours lecture where you're going to learn about Terraform modules. Right, you're going to learn how to implement Terraform modules, and in this section is just how to use the modules locally. And if you do watch the lecture and you really want to understand how you can be able to use the module after you push it into your GitHub repository or to your GitLab repository, please do feel free to add a comment so I can maybe do another recording to show you guys how you can be able to use the module when you have pushed it into your GitHub account. So I look forward to seeing your comments, and ciao. Let's dive right in. Last week we saw how to use Terraform modules, and today basically we are going to begin by looking at how to create custom Terraform modules, how you can be able to create your own modules. And with this, at least if you understand how you can be able to create your own modules, and I think that the concept of how to use Terraform modules that are pre-existing in the public Terraform registry, it makes it a little bit much more easier for you to understand, because I think it's easier to understand this than understanding the public modules if you don't know how to create them. So what exactly is a module? You have already seen that a module is basically just a reusable block of code, right? So you have multiple Terraform configuration files, and you can be able to reuse them to create multiple infrastructures. So you can be able to call them inside multiple infrastructures. So creating modules in Terraform is all about the folder structure. It's nothing different from what we have been doing before. Basically, like, it's nothing different from what you've been doing. It's just a concept of how you're of how you're putting in the folders, basically. So, and what does this mean? So let's I'm going to create let's see the into Primus, and then we are going to create up cd into, I'm going to put it anywhere. Yeah. Let me create a new directory here. I'm going to create okay. Now let's do a mkdir. Let's create a folder called project. Now let's cd into the project folder. Now let's open this project folder directly. So I have this folder called project. Now I'm going to open this folder with VS Code. Okay, forget about the folders before. It's just organize my things. So the folder that is called project, that is folder that I'm going to open with VS Code. So we have this folder inside here. Now inside this folder, we are going to create another folder. We're going to create another folder inside this folder that is called modules. And again, it must not be called modules, right? It can be called anything. Then now, for example, now I'm going to create again another folder inside this project folder that I can call it maybe dev, for example. Let's do it like this. So I have a folder called modules and I have a folder called dev, and it's all about folder structure. It's not about the names of the folders. Again, I want to make that clear. So it's not because I called it modules that it means that it's modules inside. So, but what actually makes it modules is basically how you've written the code that is inside the modules folder. So inside the folder that is called modules, you can be able to create separate folders now for various modules that you want to be able to create. For example, if I know that in my environment, we are always creating EC2 instances, okay, it's very often, we are always creating EC2 instances very often, then I can create a module for EC2, okay? So we're going to create a module called EC2. And maybe we're also using S3 buckets very well, right? We are creating S3 buckets on a daily. I could also create a module that is called S3. So let's create a module that is called S3. Now, let's also create another module that is called RDS, maybe because we're also using RDS on a daily basis. Let's also create another module for maybe VPC, right? You can create a module for maybe VPC. So these are just folders that I'm creating, right? There's nothing special about these folders. They're just directories. So now inside the EC2 module, we can now start adding our Terraform configuration, right? So, and what are the basic things that are supposed to be in your Terraform configuration? The only things you're going to be adding in our modules are basically going to be maybe something like the main.tf, okay? And our main.tf, what is the main.tf going to be used for? Our main.tf is just going to be used to do any particular configuration that is related to just EC2. Inside your modules, you don't do things like provide. You don't do things like you don't do things like and I say you're not going to be doing things like profile configurations and particular provider configurations and all those things. You're not going to be creating things like Terraform, TFVAS, and all those kind of things, right? So when you're working with your modules, basically the only thing that you're going to be creating is just going to be just the resources. So in main.tf, you're going to add just your resources. You're not going to be adding a Terraform configuration block or all those things, because the thing is, if you want to use multiple modules like this, you can only use the Terraform block configuration just once. You cannot use it multiple times, right? So you cannot do the configuration for the Terraform block inside here and do it again inside here, do it again inside here. Why? Because at the end of the day, when you're going to call all these modules to be able to use them, Terraform is going to tell you that you have duplicate Terraform blocks. Right. So when you're creating your modules, the module contains just the Terraform configuration for that particular resource. It's not going to contain anything more. So in your main.cf, we can add our source code for the creation of an EC2 instance. Then at the list also, we can also be able to have a variables.cf. We have a variables.cf where we define all the variables. Then we can now also have the main.cf. Sorry, the data. The output is also important. You can also have output.tf. All the various outputs that are going to be gotten from this module, you're going to have them inside the output.tf. And I think this is basically it. So we can now copy all this. We can now copy main.tf, output.tf, and variable.tf, and also paste it inside all these other ones, because they are also going to follow the same configuration. So you see, they are all following the same configuration. Inside EC2, we have just a main.tf. In our main.tf now, we're going to add our source code to be able to create an EC2 instance, right? So let's go to the Terraform documentation. And we want to open the Terraform AWS provider. So we want to create an EC2 instance. So let's go down to the EC2 section. Elastic Compute Cloud. So we open Elastic Compute Cloud, and we want to create an AWS underscore instance. And then we're going to copy the resource to create an EC2 instance. So I'm copying this. So to create an EC2 instance, we need the AMI, we need the instance type, and then we need the tags. So at the same time, we're going to add the variables for all these parameters. So also let's split also for the output. This way we can do everything easily. So let's add a variable that is going to hold the AMI. So we are saying that we're going to add a variable called variable instance AMI. And then it's going to carry the description instance AMI. And it's not going to have any default value. Okay, it's not going to have any default value. It's going to have just the type. And the type is going to be equal to string. So we are also going to create another variable. And the variable name is going to be equal to instance type. The description is going to be equal to instance type. Instance type. And the type is going to be equal to string. like that. So we are even going to, so for the name of the EC2 instance, let's add a variable called variable instance name. The description is going to be equal to instance name. And the type is going to be equal to string. So we have these three variables representing these three values. So let's go ahead and replace them here. So we have dot instance AMI. We have dot instance type. And then here we have var dot instance name. Okay. So we are good. We have made everything parameterized. And one thing about when you're creating modules, whenever you're creating modules, you need to parameterize everything. Everything is supposed to be a variable. When you're creating modules, that is basically what makes the module. The idea why it's a module is that everything is supposed to be parameterized. The user should be the one to override your values to provide their own values, and not so. Basically, everything should be provided as parameters. So, for example, for the instance name, we can provide a default value, right? We can say default is going to be equal to default value is going to be equal to demo. You can see maybe default value is going to be equal to demo. For the instance type, you can see default is going to be equal to, you can say it's going to be equal to T2 micro, just in case. So now for the output now, and everybody knows what an output block is. The output is used to get all the attribute refs of a particular result, right? You can be able to output them to the terminal once Terraform apply is done. So we want to create an output block. So we can see, for example, maybe we want to always get the IP address of, we always want to output the IP address of this EC2 instance, the public IP address, and maybe the private IP address, and so on, right? So maybe we can output the public IP address. So we can say output, and we can say instance. You can say instance underscore public underscore IP. Change that to an underscore. And then this is going to be equal to AWS underscore instance dot web. Or is it going to be equal to let's say it's going to be equal to value is going to be AWS underscore instance dot web dot public IP. So this is the value of this output. So maybe we can also what other output can we put? So let's say output instance. Let's say let's get I'm not sure which other important information you want to get from the creation of an instance resource. Maybe you can also get the public DNS. So let's say instance public DNS value is going to be equal to AWS underscore instance dot web dot public DNS. So we want to output these two parameters. So this is basically how to create an EC2 instance, and we have parameterized everything, right? Everything is described as parameters. We can do same for RDS, and we can do same for we can do same for S3, we can do same for VPC. So let's do same for all the other guys. So I'm going to remove this since we are done with this. Remove this. And for RDS, I can simply just let's begin with VPC. With VPC first. So we want to create a VPC. And then we can come back to our code that we already created. So I'm going to go to so let's go to Primus Learning app. That's man me later. Okay, I think we have VPC creation somewhere. Okay, so I just want to copy this code to create a VPC. Since we already have it, we don't need to recreate the whole thing, right? It will be a waste to recreate everything. So we're just going to copy this up like this. Yeah, we have lots of variables or locals missing. We are going to fix this. So let's open our variables files and do this. Okay. So I'm going to come down here. So here we have the creation of the this is the creation of the of the RDS, right? So I'm going to remove the creation of RDS. All this one here, the RDS creation, I'm going to remove this from here because it should not be here. I'm going to put the RDS creation in the RDS one here. But for now, we're going to remove this and concentrate with just the VPC part of things. So let's remove this and concentrate on the VPC part of things. So here we want to begin with the VPC CIDR, right? We don't have a variable called VPC CIDR, so we need to create it. So let's create the variables. So variable VPC underscore CIDR. You can see automatically it fixed that, and then you can see that description is going to be equal to VPC CIDR, and the default is going to be equal to, let's say, 10.0.0.0/16. And the type is going to be equal to string. Let's create again variable. Let's say variable VPC underscore tenancy. The description is going to be equal to VPC tenancy. Default is going to be, let's see, what was the VPC tenancy we were using? I think tenancy is equal to default. Tenancy is equal to default, I think. It's default tenancy. Let's see what is the value we're using. Where is the variables? Variables.tf. Yeah, VPC tenancy is equal to default. So let's what is the type? The type is going to be equal to string. So let's create another variable for the VPC name. So variable VPC name description is going to be equal to VPC name, and we can say, okay, default is going to be equal to demo VPC, and type is going to be equal to the type of variable is string. So here we can now come here and replace it with the name of the VPC. So we can say var.vpc name. So let's do the same for the internet gateway. Let's create another variable for the internet gateway name. So I'm just going to copy this, and then I'll change this to internet gateway name, internet gateway underscore name. And then I'll call this internet gateway name, IGW. Then I'll call it demo gateway. Then we'll come here and we'll replace this with a variable var dot internet gateway name. Very direct stuff. So for let's provide a variable that is going to hold the public subnet. Let's provide another variable for the public subnet and the private subnet. I'm going to remove these count parameters here, because when you're creating modules, you don't need to have count parameters, because the module is going to treat just a single resource. If we are going to add a count, we are going to add it when we are using the module now to create our resources. So in the module, you don't need to have a count parameter. So I'm removing the count parameters in the module that you guys added. So the CIDR block of the public subnet is just going to be coming directly from a variable, maybe var dot. We're going to give it something. So let's give the variable for the public subnet. So we're saying variable. Let's say public subnet underscore CIDR. The description is going to be equal to, the description is going to be equal to public subnet CIDR. The default is going to be equal to, let's give a default value. Let's say the default is going to be 10.0.1.0/17. And let's say the type is going to be equal to string. That is a public subnet CIDR. And then we can say variable, let's say public underscore subnets underscore name, the name of the public subnet. Let's say the description is going to be equal to public subnet name. The default is going to be equal to demo underscore public underscore subnet. And the type of variable is going to be equal to string. So we can come here and then we are saying var.public subnet CIDR. And then we can also make this parameter a variable. So let's create another variable to hold that boolean. So variable, make public IP on launch. Variable, let's call it public underscore IP underscore on launch. Let's say description, create public IP on launch. And let's say default is going to be equal to true. And the type of variable is going to be equal to string. So here we are saying that this variable, like I said, because it's a module, everything is supposed to be parameterized. var public subnets IP on launch. And the name of the public subnet, we remove this and replace it with our variable. Sorry, up var dot public subnet name. Just like that. So we do same for the private subnet, remove the count parameter. And then we're going to copy these three guys, copy, and then we're just going to paste and then just rename. You can see what I'm doing to make it faster. So private, private, and private. For the private subnet, we don't need this parameter called private IP on launch. We don't need this because the private subnet is only the public IP. So this one is okay. So we just need to change just these ones. Changing just these ones. Demo private subnet. And we can change this one to 2.0/17. So we have private subnet CIDR, we have private subnet name. That is what we need. So here we have the private subnet CIDR. So we are saying that here is var.private subnet CIDR. And here we have the name of the private subnet, var.private subnet name. Okay. Same for the database subnet. We remove the count parameter. And then we remove this guy too. And then let's create the parameters for the database subnets. So we're doing the same thing. Up. So we're saying that is going to be equal to database subnet CIDR, and it's going to be database subnet name. I change here to database, and demo db subnet as default value. I come here, I do the same thing, var.database subnet CIDR, and var.database subnet name. Guys, do the same thing here, remove the count parameter, remove the count parameter, remove.
Sir, you've not changed the IP address.
Sorry?
You've not changed the IP address.
Okay.
Then the description.
The DB subnet 3 database subnet CIDR. Okay. Thank you. So for the route table association, because we have removed the count parameter, we need to remove this. So we are attaching this is the public route table. So we are saying that we are attaching it to AWS underscore let's let me do this way instead. I'm just going to okay. Let's AWS underscore subnet dot public subnet dot ID. So, and then for the private route table, AWS underscore subnet private subnet dot ID. So that's how it's supposed to be. And then route table, we're going to create public route table. Let's give a name for our public route table. So up, we want to add a name for our public route table. So we are saying variable public minus route table public underscore route table underscore name. So description is going to be equal to public route table name. Default is going to be equal to demo public route table, and the type is going to be equal to string. So I change here. I'm saying that this now is going to be equal to var dot public route table name. All the other things look good. So same for the private route table name. I just copy this, cool it. And then we change this from public to private. And same here to private. Same here to private. Okay. So let's do this, change this one to var dot private route table name. And up, let's go up. AWS route table database route table. So let's create another variable for the database route table name. Same thing, come here, up database, and just copy this, copy up database, voila. And then let's come here, var dot database routable name. And then here is the association AWS underscore subnet dot database AWS underscore subnets dot database dot ID. And Elastic IP, everything looks good. Let's see. Here we want to attach AWS underscore public subnet dot ID. So it's going to be AWS underscore public subnet dot ID. Let's create a NAT gateway, a variable to hold a NAT gateway name. So I'm saying variable NAT gateway underscore name. And then description is going to be equal to NAT gateway name. Default is going to be equal to demo NAT gateway, and the type is going to be equal to string. So let's say that this is var dot NAT gateway name. And then AWS underscore DB subnet. We want to create the database subnet group. So let's create a variable to hold the database subnet group. Like I said, because it's a module, everything is supposed to be variable. The person using the module should override these variables to provide their own variable names. So database underscore subnets group description DB subnets group name. The default is going to be equal to, better to use double quotes. It's going to be demo DB sub name, and the type is going to be equal to string var dot db var dot database subnet group. Subnet ID is equal to, remove the asterisk because it's just one. And okay, this is going to carry name, my DB subnet group, more like, okay, let's see. DB subnet group name is equal to this, the name tag. I'm not sure. AWS one is called DB subnet group. What is the difference between name and name tag here? Name tag here normally should be name, except otherwise. But we can use, these guys can take the same variable name. These guys can use the same variable name. So yeah, so that is that for the VPC. We have made everything variables up. You can see everything has been parameterized. And now if you want to get any really, if you want to get any output parameters, then you can get them from here. But the important output that we want to get from the VPC is like things like the ID and so on. Because the thing is, when you're going to be using when you're going to be calling this module to be able to use this module, if you never outputted a particular parameter, then there's no way you're going to be able to reference it and pass it to another module, right? So that is one thing that is important. If you want to be able to use a particular parameter in a submodule, then first you will need to output that particular parameter. So let's say output, for example, let's output the VPC, let's always output the VPC ID. So let's say VPC ID. And I'll show you guys what I mean by why you need to output the ID of the VPC in just a minute. I'll show you guys exactly why this is very, very important, why you need to output all these parameters. So let's say value is equal to AWS underscore VPC. dot vpc dot id. You want to output the ID of the VPC. Let's also output things like the ID of the ID of the various subnets. So let's do output public underscore subnet underscore ID. And the value is going to be equal to AWS underscore subnet dot public dot ID. Same thing, output private underscore subnets underscore ID. So let's say value is going to be equal to AWS underscore private subnet dot ID. Same for the database subnet output is equal to AWS output is equal to database underscore subnet underscore ID. And let's say value is equal to AWS underscore subnet dot database dot ID. Okay. So we're outputting all the IDs. Another important parameter that you might also want to output can be things like the public subnet CIDR, the public subnet ID, the database subnet CIDR, and all those things. They are also very important parameters that you might want to output because you might want to reference these parameters later on to be able to use them outside of the module. So that is why you need to put them as outputs, and we'll see exactly what it means when we start trying to create infrastructure using all these modules at the same time. So this is how you're creating your module. So you're basically making everything parameters. Same thing we've been doing so far, but we're just making sure everything is a variable, right? That way the user can be able to provide their own values to these variables if they want to, right? For the values that don't have default values, I will need to provide the values myself by passing my TFS. So we have done for the VPC. And I think basically this is everything about the VPC. So we can also even add another module for like security group. So let's call it security group. Let's call it security group. And inside there, let's do this up, copy, paste. Yes. Okay, now let's close for VPC and let's say we are done, assuming that is working. And then let's come to S3. We want to create an S3 bucket. So let's go back to VPC. How do you create an S3 bucket? So we can, I'm not sure we have any S3 resource here, but let's copy the creation from somewhere. So let's go to the S3 documentation. We're looking for S3 bucket, simple storage service, and AWS underscore S3 underscore bucket. You want to create an S3 bucket. So let's copy this. So this is the module you want to create for an S3 bucket. Let's put a variables folder as usual. And let's put the output. Okay. So the bucket name, let's begin with this guy. So let's create a variable that is going to hold the bucket name. So variable bucket name. Simple as that. Description, bucket name. Okay. And then let's do up I'm not going to provide a default. I'm not sure. Let's say type is going to be equal to string. There's no need providing the default value because it's not really really relevant. Either ways, you cannot create multiple buckets with the same name. So it's irrelevant to have a default value. Var bucket name. One thing that we want to have is to force destroy. So I'm going to turn force destroy. So let's add the parameter force destroy. And let's make it a variable. Force destroy. So let's say description is equal to force destroy bucket. Default value is going to be equal to, for me, I want the default value for force destroy to be equal to true for me, because I always want to force destroy my bucket. That way, if something happens, I don't want to like lose. I want to be able to destroy the bucket even if it has data inside. So I need to turn this on. For me, I always want to turn this on all the time. Force destroy bucket. So yeah, for the output parameters, let's do output and let's output the name of the bucket. So let's say bucket name, and value is going to be equal to AWS underscore S3 dot bucket. Let's show you some example. Let's call this let's just call this bucket instead of example. So dot bucket dot dot ID. The ID of the bucket is always the name of the bucket in the case of S3. So yeah, I think this should be it about S3. So we're creating an S3 bucket, we have the output and then we have the variable, and that is done. So let's close that up. So what is left? We have RDS. We are creating our RDS here. Now here we want to create a relational database, and inside here we are saying AWS underscore subnet dot db subnet group dot name. But now this is where the interesting stuff start happening. I don't really want to like already reference this module inside here, because we are creating this database subnet group. This database subnet group is created in a different module, and before then, if you want to use this database subnet group name here, then you need to import the module for VPC inside here before you will be able to use this to create your RDS instances. So generally that would be the way to go. So okay, I'm looking at the best way we can manage this. I don't let's use a data source to get the database subnet group name. But it's going to be very, very tricky to do this. So because of that, so now one thing when you're creating your modules that are targeted for a particular infrastructure, the first important stuff is to be able to understand the whole architectural design of the whole infrastructure, right? Like right now, I'm thinking of the way to go with this. The best way for me can be maybe to remove RDS, and we're going to put RDS inside here. This is the best way to go, is to put RDS.tf, is to put RDS inside here, and then we're going to remove the RDS module. The reason why we're doing this is because this is particular to our own environment. Because I don't want, because you see here I have AWS underscore subnet group.db.name. This parameter here is not available inside this Terraform configuration. It's available only in the VPC configuration, right? And the only way that I'm going to be able to get this name inside here is by making, if I want to get this name inside here, then I need to make it a variable, and then I can be able to get that variable after. So still we can be able to make this work. Let's remove this and make this work in a different way. So I'm going to delete this guy here, and then we'll see how to make this work using the parent modules. So how are we going to fix this here? So let's open the variables.tf, open it in a new tab, same output.tf, open it here, and let's make the things variables. So for this one, I'm going to create let's create a map variable like Ryan wanted to do earlier. So let's say variable database. I just click database config. Okay. Description database database configuration. One or two something. Database configuration. And let's say default is going to be equal to, let's say default is going to be equal to, it's going to be equal to map. So, and what are the various things that we have in our map? So we're going to have identifier. Okay, we're going to have identifier, and we can say identifier is going to be equal to, and then we can put the identifier, and then we can say we're going to have allocated storage. Allocated storage is going to be equal to, we have allocated storage, and we are going to have the storage type. So we're making all the database parameters here a map. Basically, that's what I'm doing. So storage type is going to be equal to null. I'm putting them null for now. Then after I'll copy and paste the various default values. And the engine is going to be equal to that up. I'm not sure with we don't really need commas in Terraform maps, because Terraform handle, since you're putting them in a separate line. The engine, we can put the engine version is going to be equal to that. We have instance class, and then we have username. Then we have password. We have parameter group. Okay. We have DB subnets group name. We have VPC security group IDs. And we have skip final snapshot. Okay. So this is going to be equal to true by default. Up this guy here is going to be equal to that. VPC security group IDs is going to be a list of IDs. So this guy here is going to be a list of IDs. And then DB subnet group name, yes, is going to be a string. And then what is the default value of the parameter group? So here we just copy this one like this. Parameter group name, password, and that we're not going to put any default value. Instance class, we can put db.t3.micro instance class. And the engine version is going to be MySQL 8.0 engine version. The engine is going to be equal to MySQL. Copy that. So you can see what we're doing. We're basically just making the parameters configuration a map. Because if we had to create this single one of these like variables, it's going to be multiple lines of code. So when you do this, you can see now it reduces the number of lines of code that you can write. So allocated storage is going to be equal to 20. And then identifier is going to be equal to a string. And by default, By default, the identifier is going to be equal to demo db. So now let's reference our variables. Who can tell me how to reference these variables? How do I reference the identifier? So I'm going to change this to an underscore. So who can tell us how do we reference our variable? So here I'm going to say variable type is going to be equal to map. I'm going to call it map of type is going to be equal to map of type. I'm not sure if Terraform still supports maps of type any, because the thing is that inside here I have values that are equal to list parameters. I also have this, I also have that. So I want to be able to use a map of type any. I'm not sure if it's still supported right now. Let me see something. Terraform map of type any. Type constraints. See something. I don't want to call it like collection of values where each is identified by a string label. Okay, yeah, you can use the keyword map is a shorthand for map of type any, which accepts any element type as long as every element is the same type. No, 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 no. All the elements are not the same type. The full form. Maps can be made with places and the columns or equal to signs. Oh, object collection of name attribute that each value have their own type. So I think we might need to change it to an object because remember last time I told you guys to do research. I'm not sure if everyone did it. I told you guys to do some research and tell me what the difference between a map is with an object. And now, like right now here, you see we want to use a map, but it's not possible. Why? Because you see that a map is a collection of values where each is identified by a string label, right? But if each is not identified by a string label, then at least Terraform is telling you that all the parameters should be the same. All the values of map should accept the same value. For example, you cannot have a map like this in Terraform and you have some values that are list and some are booleans and some are strings and some are numbers. You see, this is mixed, this is mixed. And this in Terraform is saying that it cannot support this in a map. So if you want to create something like this where where values can have different types, then you want to use something called an object. You can see an object is a collection of named attribute, but each have their own type. So you have a collection of key value pairs, but each of these key value pairs have their own types. So you can see an object is just the same way, like you're going to have a normal, you're going to have a map, but this time around you can have something like this. You can see name John is equal to that, and this is equal to that, and it's basically you can see it's basically different because now each particular one has their own type. So we now need to switch to object instead of using map, because a map cannot support the type of parameters you're trying to pass inside here. So instead of using calling it map, we're going to call it object. But now when you call it object, you need to pass in all the type, because it's static typing. You need to pass all the types for all the various variables inside there. For example, you see here, when you're dealing with this, you're saying if you have name is equal to John and you have age is equal to this, then you need to when you're defining the type is going to be equal to name, is going to be equal to string, age is going to be equal to this. Like you're going to give a list of all those parameters, and each one you're going to give its type, right? So this is what we need to do here. So we are saying that we need to basically recopy this. If you're understanding me, I'm saying that we need to recopy this and paste it inside here. And now we now need to give the type for all these guys. So what is going to be the type for identifier? Identifier is going to be equal to string. Allocated storage is going to be equal to number. Storage type is going to be equal to string. Engine is of type string. And here it's also a string. Here is a string. Here is a string. Here is a string. Same for parameter group name, it's a string. Up string, and here it's a list of type string. And here it's a boolean. Okay. So hope this is clear. The idea of us changing this to an object, who doesn't understand why we're changes this to an object, and exactly what all this means, please, before I continue. Before we continue, who doesn't understand what an object is still, and why we are passing the objects, all the keys and their various types? All right, if it's understood, who can tell me why? Who can tell me what an object is? What is the difference between an object and a map, and why are we statically typing this and passing the various types to the object keys?
Sure, because with an object you can have all sorts of types, but you need to assign them for each and every one of them. While for the map you can't do that, especially when you have many types of data inputted like that.
Okay, who supports what is said? Who has a different item? So we all agree that that is true. Who has another theory? Anyone else? Tell me what an object is. What is the difference between an object and a map? And why are we doing this? Yes, Evira.
Okay, so we're using objects because objects are not variable specific. With objects, you can use several variables, but with a map, it is variable specific. So you can only use a particular type of variable.
Yeah, if I wanted to put that in the more like the best way to put it is about the types, not the variable.
Okay.
Right? It's about the types. The difference here is about the type that is coming inside here and not the variable, actually. When you have a map, okay, when you have a variable has a type, right?
Okay.
Now, when you have a map is a bunch of key value pairs. Each key has a value, and we're talking about the type of the value. Is the value of type number, or the value is of type string, or is it of type list, right? So if you have a collection of data, and inside this collection of data, if all the various keys, if the values of these keys, okay, are not uniform, which means that they are not all strings, or they are not all numbers, or they are not all lists, okay, as far as the types are different, then you can no longer call it a map. In Terraform, let me say in Terraform, because in some programming languages, you can't use a map of type any, and it's going to accept all of any of that type.
Okay.
So when the types are different, for example, you can see here we have types that are string, you have values that are numbers, you have values that are lists, you have some that are booleans. You cannot do this, you cannot use a map, because a map only support values where they are all identical. If they're not identical, then you cannot support a map. Then you need to use an object, right? So with an object, you can be able to have variables that have different types. So, but now the only thing with an object is that you now need to statically provide the variable types for all the keys in the object.
Okay.
So for each and every one of these, you now need to exclusively define what type is it actually. And if you kind of think of this, kind of have me thinking about something that is also very important. When you look at a variable of type list, okay, when you look at a variable of type list, let's look at what a list is. So we have list, a sequence of values identified by consecutive whole numbers starting with 0. The keyword list is a shorthand for list of any, which accept any element type as long as every element is the same type. So you can see this, you have the same thing with a list, okay? A list is a group of elements where all the elements have the same type. Now, what if I want to have a list of elements, but all my elements don't have the same type? Then what can I use what can I use instead of using a list? So I need to think of
Okay.
something that I can use. I don't know. Maybe there's something else that you can use, but then yeah, that is just the gist. So if you don't want to use a list, then you can always use something else. If you want to have, if your values have different type, you also have what we call a set, right? A collection of unique values that do not have any secondary identifiers or ordering. So this is a thing. If you have a list and the values in the list have different types, then you can use a set, right? Because a set is much more dynamic and can accept values, I think, that have different types. So understanding the types of variables in Terraform, and like you have done so far, understanding all the various types is like very, very important. It's like the most important stuff that you want to like get very, very well in Terraform. Then you also have a tuple, a sequence of elements identified by a consecutive whole number starting with 0, where each element has its own type. So now you can see here here is a tuple, and basically you have that. Yeah, so kind of looks the same thing. Still looks like so you have here the schema for tuple is this, and you can see this. So you can use a tuple or you can use a set. So you can see if you have a list of elements where each has its type, then you do that by using a tuple to represent them. So same thing for when you're using objects, you can do that. So now when we have our objects, how can we be able to define how can we use a particular parameter in our object? For example, if you want to pass the identifier, how do we reference the identifier? How do we reference the identifier? How do we reference the identifier?
So maybe var dot identifier.
Var dot
Identifier because the key name there. Bon, there's default before it.
no var dot database config
Yeah.
and identifier. It's a bunch of key value pairs. You're getting the keys. I was looking at what Terraform is doing, and I wanted to change this to this so we can save more space. So if you come here, you can see here, you can, when you're defining optional objects type attributes, when you're defining your objects like this, like you have a type object, you can basically directly add the default inside like this. Instead of passing the thing, you can a required attribute. So we can use optional, and then we pass the default values like this. This way we don't need to pass the values inside here double times like this. So basically what we can do is here we can call this so we can use here, so we are saying that here we can say optional, and we can say that this is going to be string, and the default value is going to be equal to this. And then we remove this. So we can do this, something like this for all the various parameters. I think type objects. Let's see. So we can do the same thing here. Optional string. Oh, let me see something. No, I'm gonna leave it this way because I don't want to make most of them optional. I want to leave the default value to be there. So let's keep it this way. So let's allocate it storage var dot database config, and then allocated storage. var dot database config. I'll copy, paste. So you have storage type, you have engine, you have engine version, instance class, you have username, you have password, you have parameter group name, you have DB subnet group name, VPC security group IDs, and then you have skip final. Okay, so that is the config, and we can up as output, we can output maybe the database username and password first, or the database. So output, we can say DB endpoint, output DB endpoint value is going to be equal to AWS underscore DB instance dot endpoint. Let's output also output let's output db username. Value is going to be equal to AWS underscore that dot username. Output db password. Value is going to be equal to AWS underscore db instance dot password. And we can, because the password is sensitive, we can mark it as sensitive. Sensitive. True. And up, I think this should be good. Database. Let's print the data, the default database. Anyways, you are not creating a default database name. So that is good. So we have a database username, database password, database endpoint. With this, you can be able to connect to your database. I think the endpoint, the username, the password. What is what else? What else do you need? I think yeah, I think this basic info you should need to be able to connect to the database. Okay, so we have done the configuration for the RDS resource. And that is it. So what else? Security group resource. So let's finish up with the security group. Let's go back to our source code. Security group.tf. So this is a resource to create a security group. Copy that, come back here and paste. So let's go to variable.tf, splits open, and let's make the security group name a variable. So we are saying variable security group name description is equal to security group name. Oh, is this? The default is going to be equal to demo minus security group. The type is going to be equal to string. Okay. So let's create another variable to hold the security group ports. Variable security group ports. So description is equal to security group ingress ports. Default is going to be equal to up. It can be empty, and then type is going to be equal to list of type string. So let's come here up. You can see var.security group name. And now here we have AWS underscore vpc.id. But remember, we're not creating this VPC resource inside here. So it's going to be a variable, right? Because we're not creating it inside here. So variable VPC ID. Description is equal to VPC underscore VPC ID to create security group in, and the default is going to be equal to null because you don't know it, and the type is going to be equal to string. And then here remove this var dot VPC ID. Okay, var dot security group ports is good, and the security group name is equal to var dot security group name. Now I think that is okay. Up ingress egress. Okay, the next thing, let's provide output to get the security group ID. So output security group underscore ID. Because if you want to reference the security group somewhere, it needs to have the ID outputted before you're going to be able to reference it. We'll see exactly why I keep on saying this when we start trying to use these modules. So you have value. What's security group ID? Value is equal to AWS underscore security group dot RDS security group dot ID. Okay, what else do you need from the security group? I think that is it. So we have parameterized everything. I hope so. Everything has been made parameters, both the security group, the VPC, the EC2 instance, and yeah, one thing that we can also add to our EC2 is the user data. So we can say, let's say user data is going to be equal to, and then let's add the variable user data. Description is going to be equal to user data. Type is going to be equal to a string. Default is going to be equal to null. And default is going to be equal to var dot user data. Okay. And what else? So you can see what a module is. This is basically what a module is. A module is basically a Terraform configuration that has no input, has no value, has nothing. And you're not going to be using this module directly. The module is just it's like the interface, right? When you say an interface, is like a configuration. It doesn't have an implementation, right? It's just the interface, exactly how do you create a particular resource. And there are multiple ways of doing this. I'm not saying this is the only way you can do this. You can, if you don't want to separate this into folders like you have done here, then you can still create a module by basically putting all these, in fact, all these things, putting them inside the same directory. You could remove all of these, put them inside here. But the reason when you do this separation, it also helps you to be able to stop importing things that you don't really need. For example, if someone wanted to create just an EC2 instance, then they are going to import just the EC2 instance module. You see? But if you merge all of them together, then someone is going to import everything, meanwhile they don't need everything. So that is the reason why it's good to do this separation. That way, if someone wants to create just an EC2 instance, they can import just the EC2 instance module and use. So what and how also does a module help you in an environment? A module also helps to ensure that consistent workflow. Okay. For example, if you have a way that you always create your EC2 resources, when you declare it as a module, you now also help the part where someone is going to try to create their own configuration differently and put their own parameters. Another person is going to do it differently. So when you have everything, when you have it as a module, it helps you to ensure that consistent workflow, right? Instead of someone else coming and creating and naming their own values differently, another person comes, names their own values differently. When you do it that way, you ensure a particular workflow that is consistent against all the various environments in your company. So that is why it's important to always create modules instead of letting everyone create anything randomly. So once we have our module, now how can we use this module? So say I want to configure my dev environment, and I want to use these modules to configure my dev environment. So I can create a folder, for example, called dev inside here. Okay, it must not always be inside here. It could be external. It could not be here, or whatever the case. It could be inside here or not. And you can also publish this module. First, let's push this Git module into our GitHub repository, for example. So we can push this module in our GitHub repo. And the way you can do it is, each of these one is going to be its own repository, its own module, because each of these ones are basically modules on their own, right? So they can have their own GitHub repositories. Or yeah, that is the only way to do it. But because if you had them all inside the same file, then you can go ahead and push them directly. And I will show you the various times you might want to like put everything in the same file, and the times where you want to like separate them, where you want to separate them like this. So this is what you call the child modules. We can now use these child modules now to create now a bigger module for a particular infrastructure, right? That is going to be stored differently. So that is what we can do. So let's go ahead and try to use this module to create some infrastructure. So how do we use the module? So now we want to use the module to create a dev environment. So when you want to use the module, the first thing you want to reference now is, now let's do our provider configuration, right? Let's call it maybe provider.tf. And inside provider.tf, now we're going to do our basic provider configuration that we are always doing. So because now we are using the module, right? We are no longer, we want to use the module, so we want to create the infrastructure. So I'm going to open my previous code. Oh shit, I changed my folder structure. So I need to up new window. Oof. Um, open. Where is the main.tf? Okay, so let's copy this, our Terraform configuration block. Up. I'm going to remove the default tags. Okay, so now let's go ahead and create our resources. So now when I want to create an EC2 instance, I'm going to create ec2.tf. When I create ec2.tf, instead of me going to Terraform documentation to get the EC2 provider configuration, I want to create an EC2 instance from a module, right? So this here is going to be from a module. So what you're going to do here is you're going to say module, and the module is going to be equal to EC2. So when you say module and module is equal to EC2, now the first thing that is important that you need to define is what we call the source. Where are you getting this module from? And because we have our module defined locally and we are not calling our module from like some GitHub repository or from somewhere, we now need to access now using the relative path, right? And where is the relative path to this folder called EC2? Who can give us the relative path to this folder called EC2? What is the relative path? Who can tell us the relative path to this folder called EC2? Linux 101. What is the relative path to this folder called EC2? Guys,
So let me try. Is it January 2024 slash?
no, the relative path to the folder called EC2. The relative path. What is the relative path, guys? I'm inside the dev folder I'm inside here, and I want to reference this folder inside here. What is the relative path to this folder from here? From here, how do I come here?
dot slash.
Sorry?
Dot slash.
Dot?
Dot dot slash name. Modus slash EC2.
Dot slash module slash EC2. So you can see when I reference this source is equal to dot slash module slash EC2, automatically you see it starts giving me errors. You see, required attribute instance AMI not specified. An attribute name instance AMI is required here. You see, so when I import this module, automatically it starts giving me attributes that are required. So you can see it's telling me that when I import this module, I need something that is called instance AMI. You can see, and it's also telling me that I need something that is called I need instance name. You can see I'm not typing any of these things. It's automatically getting them from the module. And how is this getting these parameters? These parameters that is getting for me here, if you come back to this module inside ec2.cf, you open this module inside here, they are basically all these variables, instance AMI, instance type, all these parameters. They are those parameters that is giving me instance AMI, instance name, instance type, all those parameters that we have inside here. So that's why it's asking me for all these parameters. So if you go to, and the reason why it's asking why he never gave, the reason why Terraform never gave an error on all the other ones, who can tell me why Terraform only gave an error when I remove this? Why is Terraform only giving me an error for this attribute called instance AMI and not for all the other ones? Why is it only requesting for those other variables and not all the other variables? Because what it's asking me is the variables. That's what it's asking me for. The variables are what we're going to be using as input to pass inside here. Why is he asking me for instance AMI, but he's not asking me for instance type and all the rest? Why is it asking just for instance AMI? Who has an idea? Why is it asking not just for instance AMI?
Is it because you did not give default value?
Yeah, because instance AMI never had a default value. All right, so for the instance AMI, we never had a default value. So that is why it's asking us for that is why it's telling us that somebody here is telling us that instance AMI is needed inside here. So if we come down here we need to provide the instance everything. So we need to provide inside here, we need to provide the instance AMI. Okay, and here we can provide the instance name. And here we can provide the instance type. Okay, so that is how you use a module. So now here I can say instance AMI is equal to, and then now I can go copy the AMI and come and paste here. But the interesting thing that I always want again to do is, instead of passing the AMIs and everything, so let's go ahead and get the AMIs for the EC2 instances. So let's go to EC2. Say, for example, let's go to instance catalog, and we want to create an instance with this AMI. So let's copy this AMI, paste it here. The instance name is going to be equal to demo virtual machine, and the instance type is going to be equal to t2.micro. So this is the basic config to use our module to create an EC2 instance. Because here we're just providing the values to our variables. Here we're just providing the values to our variables. We are not putting any default thing again like AMI, instance type, user data, because they were all already made variables. If you want to provide the user data, I just simply say user data. Okay, and when I'm saying user data here, the user data that I'm calling here is very important, guys. The user data that I'm calling here is not what is inside here. I'm calling but the variable. The variable are the inputs that you're going to be passing when you want to use a particular module. Okay, it's no longer these resource names here. These ones are not what you're using. Because if I come here, for example, if I come here and I type AMI, if I come here and I type AMI, you see inside here I type AMI. You see, it's an error. You see what it's saying? Unexpected attribute. An attribute named AMI is not expected here. Because AMI is not expected here. It's expecting a variable. is expecting the variable. So this guy here is referenced by this guy here. And when you call this now as a module, what you're providing is the value of this variable and not the value of this parameter inside here. Okay, so this is dependency injection. You're going to inject it from this guy, you're going to inject the AMI. Then this guy is going to call this module now. He's going to inject that value to this variable called this one. And this one here is going to inject it now to the AMI value. Okay, so this is called dependency injection, like the real dependency injection. You're not referencing but AMI inside here, you're referencing but the variable of the AMI because this here is a module. So the instance AMI is equal to this, the instance name is equal to this, and the instance type is equal to this. And the user data here, you can provide the user data if you want to. Or if you don't have user data to provide, then it's still good. But now, what if you want to provide some user data? Let's say we have something like Nginx, for example, Nginx.sh. And we can provide it as last time we can provide it as a file parameter. So we can provide it as a file. So let's see Terraform file function. Terraform file function. Okay. So we can use the file and the path. So we can, like this, you can see file and then the path to where the particular file is found. So we're saying that user data is going to be equal to file, and the path we are saying that is going to be equal to nginx nginx.sh. So file is equal to nginx.sh. Usually I always want to use the path.module because the path.module makes it remove some kind of thing, like the path.module helps Terraform to basically know that it should be checking it from this root directory inside here, or else you can still always leave it as nginx, and I think it's still going to work perfectly. So you can read about Terraform functions in your own read. There's a lot of functions that are very interesting to know in Terraform. For example, you can use file exists to determine if a particular file exists. You also have things like template files, render using file from Dix as template. So you can read more about Terraform functions to see some basic functions that you can use in Terraform if you want to. So yep, so we can reference our file here as nginx.sh, and inside here now you can now provide our user data to install nginx. Okay, so since our AMI is Amazon Linux AMI, we need to write a bash script that can install nginx in Amazon Linux. So we can check over the internet to see if we're going to find a bash script that is already pre-written, right? We don't want to start writing everything from scratch. So we can say bash to install. Let's I'm going to ask chat GPT to generate one for me. Right. So we are looking for a bash script to install nginx on Amazon Linux AMI. Okay, hopefully this works. At times, ChatGPT likes creating things that are going to make you debug your whole life before you can fix the script. Okay, so it says you can use this, even though normally in a bash script you don't use sudo, but for some reason ChatGPT is crazy and it's using sudo in a bash script. You don't need to have sudo in a bash script. So sudo yum update minus y, and then sudo yum install Amazon Linux extras, Apple install nginx, and then system start nginx, system enable nginx, and status nginx. Okay. So that is it, the bash script to install nginx you have gotten from ChatGPT. Hopefully it works. I don't really care if it works or not. So one thing that we want to define here is also let's say we also want to provide a key pair, right? We can say key pair, key name is equal to, let's make it a variable. So let's say variable key pair name description key pair name. There's no default value. The type is going to be equal to string. So you can see automatically as I added that variable, when I come back here, now I can be able to have key. Let's see, what was it called? Main.tf key name. Key name is equal to var dot key pair name. Now, once I put that, let's come back to our module. Here we can now pass. You can see here, if you reference here, you can now see required attribute key pair name. Automatically, as I added a new parameter, now automatically this is red. So it's saying required attribute key pair name. Key pair name is equal to. Now I can reference some key pair that already exists in my AWS account. If I don't want to create a key pair from scratch, you already know what to do if you want to create a key pair from scratch by using the TLS provider. So here I can just do this. Voila. And now we can cd into projects and cd into dev. And we can now try to deploy our Terraform using our module. So first, let's do our Terraform init. So we're saying Terraform init. So initializing, you can see initializing modules EC2 in this particular folder, initializing modules EC2 in modules, and it's initialize the module. So whenever Terraform is initialized, like we said, it always downloads the module configuration and the provider configuration. So if you come inside here, inside .terraform, let's see what is going to happen inside here. Inside here, if you open inside modules, you'll see inside here you have modules.json. So you have all the various modules that you have. You can see, and the module here is defining the source of the module, .terraform, and this is the source of the module inside here. So because the module is local, it just defines the path to where the module is found. If the module was remotely, it's going to download all the code of the module and bring it inside here. So, and we'll see that. So now that we have downloaded this, now let's do a Terraform validate to see the configuration is valid. So Terraform validate. Terraform validate. So configuration is valid. So let's check Terraform format. Why do I keep Terraform? Okay. Issue.tf and provider.tf be formatted. And then now we can do our Terraform. Terraform apply. Terraform apply. Okay, do you want to perform this action? Terraform with so Terraform want to create an EC2 instance with this name and that. So if you do yes, then up yes, you want to create this resource. Invalid parameter t2.micro instance type does not support AMI in which both UFI is equal to that. So we need to change the AMI. So let's go back and copy let's use this one. We need to switch to this other AMI. I think that is the issue. Terraform apply. So Terraform is creating the resource. Okay, so we have created our resource using Terraform. So if you check inside here, you will see, even though Terraform finished creating our resource, but Terraform didn't give us any output. The reason is because the output of the child module is not the output of the parent. Okay, the output of the child here is not the output of the parent. If you want to output the resource, then you need to exclusively again create an output.tf inside here to be able to output the resource. So if you want to output the IP address of the EC2 instance, they will need to exclusively again inside here, we need to add output. We need to add output.tf. And now if you want to get the output of the EC2 instance, then we can now say output. We can now say output block, and then we can now say output is equal to instance, for example, instance public IP. And to get the instance public IP, because remember, we don't have the AWS resource. Originally, how do we get the output of the EC2 instance? How are we getting the output of the public IP addresses? AWS_instance.web. Okay. But now, because we don't have the EC2, because we don't have the AWS resource, we are getting it from the module. Very important. So the output, the value of the output is equal to module.ec2. Is equal to module.ec2 dot, and then now you need to provide now the output. Now you can see the reason why I was telling you that you need to reference them, because you cannot be able to get an output of something that the child module is not outputting, right? And you can see here when I say module.ec2, you see it shows me only two parameters that I can output. I can only output the instance public DNS and the instance public IP. So it's only showing me these two, but meanwhile, we know that we can be able to output multiple parameters, right? But you can only output parameters from a parent module that are outputted in the child module, right? So for example, if I want to get the public IP, then I can use instance public IP like this. This is going to work perfectly. So if you want to output anything, if there's a particular parameter that you would like to use somewhere in your modules, they need to make sure that you output it. Because inside here, I cannot output the parameters of the EC2 resource directly. I cannot output the parameters of this resource called AWS_web, AWS_instance.web. I cannot output them inside here. That is, I cannot output them inside here. So I can only output something here that has been outputted in the module itself. So that is why this is very important, and that is why when we looked at how to use the custom Terraform modules last week, we saw that the important thing that you have inputs and outputs. They always show you what you're supposed to provide and what you're going to get as output, right? So these are the two important things when you're using Terraform modules: is the input and the output. The input are the values that you're supposed to give, and the output is those values that you can be able to get from running that particular module. So if you want to get the instance public IP, now we can do a Terraform apply again. And then we can do yes, nothing, and then you can see here we get the public IP address of the EC2 instance outputted to us, because we have referenced it in our Terraform module. Okay, who has a question? Any questions, guys? Any questions about Terraform modules and how to use Terraform modules? So we can come back to instances to verify if our instance has been created. And we can see our instance inside here, our instance created. I don't know if the Nginx was installed inside this instance or not. But yeah, if it was installed, then you can be able to have access to the Nginx by using the public IP address of the virtual machine and then the port where the Nginx is running. I don't think that is the important thing for us if Nginx is running or not. It's not really important. So we have used our module to be able to create an EC2 instance, but we can use the module to do more. Okay, for now we are creating our EC2 instance, but this EC2 instance is being created in the default VPC, right? What if we want to create our EC2 instance in this VPC that is inside here? So first, let's destroy everything. Let's do a Terraform destroy. So now we want to create our EC2 instance inside the VPC that is going to be created from inside this other module. So yes. So let's go back to our dev environment, and we want to add vpc.tf. So we are saying module vpc, and the source is going to be equal to /module/vpc, and now we need to provide the values for our VPC. Here you see, it's not asking for any value. The reason why it's because I think all the values have default parameters. That is why it's not asking for any value. So that is our VPC. Now we can also import our security group. So let's create a security group.tf, and then module is going to be equal to security group, and the source is going to be equal to /security group. So we're importing those two, and let's go to let's provide the variable security group ports. I want to provide the list of ports. So for example, I want to open port 80. Okay, you can open port 80. We can open port 8080. You can open port 8080 like this. So we're creating the security group and all the other things. We have the VPC that is going to be created for us. And now under our EC2 now, we want to provide the configuration for the VPC, right? And if you go back to our previous Terraform configuration, we know that when you're creating an EC2 instance and you want to create it in a particular VPC, there are some parameters that you need to provide, right? So first we need to make these parameters available in our EC2 instance. So we need to provide a subnet ID and the VPC security group IDs. So in the module, we need to first of all ensure that in the module is already having these parameters. So in our module, we need to add security group configuration. So we are deciding security groups, whatever it is VPC security group IDs. VPC security group IDs. And it's supposed to be a list of IDs. So inside variable.tf, so let's remove all the other things. It's good to remove them so we have a cleaner environment. So we want to add the security group ID. So we're saying variable VPC security group IDs. The description is going to be equal to security group IDs. The default is going to be equal to null, and it's going to have a type of list of strings. So the default is equal to list. So the default is equal to list. So also let's create a variable to hold a subnet. So let's say subnet ID. And we're saying description is going to be equal to subnet ID. And the default is going to be null. And the type is going to be equal to string. So back to the main.tf, what we want to do is we want to first define so the security group IDs is going to be equal to var.security group IDs, and then we have the subnet ID is going to be equal to var.subnet ID, like this. So now that we have defined this inside here, now we can now come back inside here to our EC2 resource. So we have our security group that we have referenced from the module, and we have our VPC that we have referenced from the module, which means it's going to create the VPC and the security group for us. Now we just need to reference those things. So let's come back to EC2. Let's come back to the EC2 here. So we want to provide the VPC security group IDs. And where are these security group IDs coming from? Who can maybe just guess? How am I going to reference the security group IDs, the VPC security group IDs inside here? How am I going to reference them? How am I going to reference the security group IDs inside here to pass them to the EC2 instance? Who has an idea? Also the subnet ID. How are we going to pass the security group ID and the subnet ID? Who can tell me where are we getting the security groups? Where are we getting the security groups from? From where are we getting the security groups and the subnet, or where are we getting the subnet ID? Where are we getting the subnet ID from? Sorry?
From the security group module.
From the security group module. VPC security group IDs is coming from the security group modules. So if you want to reference that inside inside here, so what do we do? First, when we are creating the security group, it's important. The first thing is, let's look at the security group. When you're creating the security group, you need to provide the VPC ID. Okay. So first we need to provide this parameter because we don't have it yet. And that is why I told you you need to always so if you come back here, VPC ID. Now let's come back to security group.tf. Here we need to provide the VPC ID. The VPC where that security group is going to be created, right? And VPC ID is going to be equal to module.vpc ID. So I'm referencing the VPC ID from the module. So from the VPC module, I'm getting the VPC ID. And the only reason, again, why I'm able to use VPC ID is because I added it as output in the VPC module. It's because I added here as output. If I never had it here as output, then I'll not be able to use it. Very important. So now that the security group is being created now in the right VPC, I can now be able now to come now here and I say, okay, I want to reference the VPC security group IDs. And how can I get the list of VPC security group IDs? I can get them from module. I can get them from module.vpc. But now I want to get the security groups, but it'll be difficult because I don't have them outputted. Right? So there's no way I'll be able to get the security group IDs. But if I want to get the subnet ID, I could get the subnet ID, for example, because I have private subnet and public subnet. So if I can reference the subnet ID inside module.vpc, for example, if I want to create this instance in the public subnet, I can use public subnet ID. Right? But what about the security group IDs? I cannot get them because I never referenced them in the VPC module. I don't have an output for security group IDs. So first I need to add an output for those IDs. So here we need to add output, and we can add security group IDs. And here we can now say value is going to be equal to AWS underscore VPC dot VPC. Let's how do we get I think we can just use the ID of the security group directly instead of getting it from the VPC. We can just interpolate. Let's go back here. Let's get the ID of this from the security group module. So let's say security group dot ID. But one thing you need to remember is that this is a list of parameters. So you need to add it here like this. So it's supposed to be like this. It's a list. So module.securitygroup.id. Even though we have just one, but if there are multiple of them, right, they need to loop through them and you need to provide multiples of all those security group IDs inside them. But for us, we have just one. So we can just add the list. We can just add the square brackets to this to say that this is a list, and then we can access module.securitygroup.security group IDs. So this is going to create the virtual machine in this particular subnet and using this particular security group ID. And I think that should be all about the configuration. So let's redo the Terraform init to initialize all the modules of our Terraform. So Terraform init to reinitialize everything. Terraform init, Terraform has been reinitialized. Now we can try to do a Terraform format or Terraform validate. And then we can do Terraform format and then Terraform apply. Okay. So we have issues with the CIDR blocks. 10 dot tan 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 is not a valid IPv4 CIDR block. Did you mean what? Public subnet CIDR? Did you mean 10.0? What did I put? So we have issues with the CIDRs. So let's with the default CIDRs. So let's go back to the VPC CIDRs. What did we put here? So let's let's see default. Okay, public subnet CIDR, private subnet CIDR, and that's okay. Looks like some issue somewhere. It's not a valid IPv4 CIDR block. Did you mean 10.0.0.0.0.17? So let's get the CIDR that we were using before. I think this way we don't need to create other stuff. Where's the, let's go to VPC. I think we were putting them in locals, locals.tf. No, vpc.tf. Where are the subnet CIDRs? Ryan, where did you move the default subnet CIDRs to? I can't find them anywhere inside here. Ryan. Okay, you are doing VAD of VPC CIDR accounts index thing, and then you are just automatically adding the CIDRs. So for me, I need to change this block here. I think 18 should work. I'm not sure why it's refusing 17. Because the subnetting is not correct. I know, but I still don't 18. Let's redo the init. Okay, still not valid. Let me just subnet it real quick. Subnet divider. So you want to subnet the 10.0.0.0/16 updates up divides. So we can have this one up public subnets side up. We can have this. Let's change to this. Private subnets, we can use this. and then we can use 128/17. We have 18.2. Okay, so let's redo the init. Have a subnet setup.tf. There's an issue somewhere. Up the space. Okay, incorrect attribute value main.tf database subnet.id is a string. Where is the issue? Module.vpc, you can see we have an issue in the module vpc.main.tf, and Terraform always tells you exactly where you have the issue, right? And the particular line. So for example, you can see incorrect attribute value on module vpc/main.tf. So I know that it's talking about module vpc main.tf. So I come here and it says, okay, line 111. So if I come down here, it means that on line 111, I have an issue. So on line 111, it's saying that subnet IDs is equal to aws_subnet.database.id. And it's saying that there's an issue inside this particular resource. What exactly is the issue? So you see that inappropriate value of attribute subnet IDs set of strings is required. So it's supposed to be a set of strings like this. So DB subnet group is supposed to be a set of strings. So I need to make it a list like this. So even though I'm providing just one element in that list, but I think only that should make it okay. So let's try the apply again. Okay, and now it looks good. So yeah, so our configuration now looks valid, and we can be able to create our EC2 instance, and it's going to create it in the right VPC using the right security group. And you can see we created these little modules, and then now we're able to use all these modules now to create a whole infrastructure, right? We're able to use our modules now to create a whole infrastructure. So this is how most companies use Terraform. So we create the modules, you store them in the GitHub repository, and for anyone that wants to use the Terraform code, they can just get this module and then use the module to create their own Terraform infrastructure. So normally, if we want to push the module to our Git, we'll push them like separate folders on their own. Like this one is going to be a project, this one is going to be a project, this is going to be a project, this is going to be a project, this is going to be a project. But instead of us doing it that way, because it's going to take a lot of time to create all the projects, for me, I can just create a single project called modules to push it, so that you guys can then pull the module, and then you can now try to play around with the module locally to use the module to create a resource. What I want is for you guys to be able to use this module to create a whole infrastructure. So I'll give you guys the exercise so you guys can do it. So you use the module that we have created in class to be able to create an infrastructure that is going to have an EC2 instance with an RDS, with a VPC, with everything. So I'm pushing just a module, and I'm not pushing the infrastructure that I created. So I'm pushing just this guy inside here. So let's remove this, and let's cd into /modules. So inside here, we are going to push this code. So let's go back to our GitHub repo. And guys, as I'm discussing, if you have any questions about Terraform modules, please do ask your question if you never understood anything about Terraform modules. Please, I want to answer your questions now, because tomorrow we're beginning with Ansible, and so if you have something to ask, you should ask your question now, or maybe tomorrow still, or sometime in the future. But if you have something that you've not understood right now, you can ask the question. Any questions? So we're going to make this public. Great repository. Congratulations for making it to the end. And if you're new to the channel, please do feel free to subscribe, and also leave a comment or like the video if you really enjoyed it. And I'll see you in the next one. Thank you guys. Bye.